No. No. Hello, and welcome to this new video in which I will be demonstrating how to use the cost optimization module that I published a few weeks ago on GitHub. For those who did not see it a few weeks ago, I published this very simple little module, whose objective is to help us optimize costs in our projects. What the module does is deploy the necessary resources to schedule the shutdown and startup of our instances, both EC2 and RDS. Through this module, we can program these shutdowns and these ONs in a very simple way. Here, we have a small example of what this module displays. Initially, it will deploy 2 Lambda functions for turning off and on EC2 instances, and another 2 Lambda functions for turning off and on instances of type databases at 10. We are also going to be deploying in bridge schedule, which are the ones that they are going to trigger, to the landies when it is fulfilled. The time condition that we place and the necessary roles of both the bridge event are also displayed to be able to invoke the landis and the landas to be able to turn the instances off and on. These landies are not going to pay for all our instances, but they are going to pay for the instances that have a specific tag. Here I have an example already deployed where I have a PC, I have 2 instances, and I have a database at 10. This guy writes to me, but the type doesn't matter, and if we look at the tags that the instances have, we see that we have ends. Therefore, this is going to be one of the instances that we are going to pay. And this other one too. Both instances have the tag N in ID. In RDS, we are going to see that we also have something similar. We go to tax, and in the list of tags, we also have environment, and as value of all this is displayed as code. With this small tweak, however, I have no use for the module for turning instances off and on. That is what we are going to see. How does it unfold in its entirety? We are going to see that we can base ourselves perfectly on the examples that we have here. Step number 1 is how to use this module. Remember, we can clone it or we can invoke it directly. I'm going to invoke it and I'm going to copy everything, this block of code. I'm going to paste it here. The second step is to define the variables, as I am going to define both a parasitic schedule and a schedule for RDS. I have to define both variables. So in step 2, I'm going to copy directly. Defining these variables as they are, I'm going to go to the variables file. And I put them here. Always remember to save the changes. And finally, we need to define in the case of my code I work with. TF bars, therefore. Here I have the definition of the variables, and then in the TF file I have the content of the variables. If you use it in another way, you must adapt it to the way you work. I'm going to copy this whole definition. And in the file of TF bars. I'm going to post this, but I'm going to remove these meadow lanes because I don't have anything developed deployed in my prod environment. I only made a temporary deployment in Deb. Now we are going to adapt this a bit, the taxis too. My instances have the tag in idlib, but we are going to adapt the CRUD's code to adapt it, and we can see now how it works to know the time in UTC. Simply here in the command line I put date less. In my time zone it is 12:30 at night, but useless, it is 3:30 at night in the morning rather. So we're going to schedule this to run in 4 minutes. So here we are going to put, that runs at 3 o'clock in the morning. Let's put I-35 and go. To set that these instances start 5 minutes later in the case of AR10 instances. Shutdown is much slower than in EC2 type instances, so we are also going to set the shutdown to be at 3:35, but the lit, let's go. Put it at 3:50. So we can see that he has paid for it as well as the ignition of instances, and Chuck's diaries is working, and we are also going to make a change. If you saw that I have the instances, both with the same, so that you can see that the differentiation by such works, I am going to change the tag to one of 2 o'clock, for example, to this one. And instead of Deb, I'm going to put DVD. So the module should only pay one of the 2 o'clock instances and the database at 10, and that would be all that remains for us now is to do a Terraform in it. Because we added a module, and every time you add a module in your code, you have to do an init. Then we are going to execute a plan. We see that we have 13 resources to add. I'm very tight on time, so we're going to change this plan here. Let's put 337 in the turned on. We are going to put 345 for the instances and chuck. The shutdown at 10 o'clock, we also put it in 337, and the on, we are going to put it directly at 4. Now yes, with this time change, we make the plan again. We are going to see that we have exactly the same 13 resources to deploy. The only thing that has changed are the schedule times. And we make a play. We confirm our play to make the deployment. Perfect. The 3 resources were added and one changed. That changed is the tag of the instance, which I changed manually. So we are going to change it again. In order to perform our test well, we come here and I change this tag. We put back. We save, and now in a few minutes, one of these 2 instances, the one tagged with environment, Deb should shut down, as well as the instance at 10. Let's wait a few minutes to see this happen. Well, the time is up. Let's refresh, see what happens. Perfect. We see that we have one of the 2 o'clock instances that shut down, while the other is still running. We are going to see the tag of the one that is running, and it is indeed, and while the one that was turned off corresponds to what we tested in Terraform. We told it to turn off all the instances whose tag is in DEP, with which the turning off of the instances of that tag worked perfectly. Let's give 10 to see what happened around here. We refresh. And you are also stopping so that the module also complied with what it should be, which is to turn off the instances at 10, that they would have deaded the tag. We also had the schedule and time to start these instances, the easy to type. He's going to start them at 3:45. And those of Aries, it will start at 4 o'clock in the morning UTC time. We are going to wait for these in a few minutes, and we are going to see if this part of the module also works correctly, that the automatic ignition of these instances is fine. We are already at the time fulfilled for the start of the instance. We are going to refresh to see what happens. As you can see, it is in vending with which the script worked correctly. The instance is starting right now, so that they may see that the hour is fulfilled. I'm going to do one date less here. Oops! We are at the correct time, 3:45, which is when we tell you to start the ITU instance. Meanwhile, the AR-10-1 is still stopping. It's a slow process. That's why I gave this one more time to program the start. But as you can see, we already have in running. Both instances of 18. Now we'll come back to see if starting the Aries instance works. Well, we are already in time. We are going to see if the instance of ART10 starts automatically. As we see it is stopped, we are going to refresh here. And we see that it is in starting, with which the programming worked correctly. Again, let's check what time it is. And I spent 1 minute while he was speaking, but we see that he respected the schedule that we set. And in this way, notice that with a super simple module, you can make a great contribution in terms of cost savings in Amazon accounts by turning off the district and squirrel instances that you are not using. A very common practice for development and testing environments. I hope this video has served you, and of course, if you liked the video, I invite you to like it, share it, subscribe to the channel, and please tell me what you think of the module. Would you use it? They are using it. Thank you very much, and see you in the next one.